All right. Good afternoon, everybody. Thanks for joining us for our online software training with Stan. This is the second time that we're offering this. We did it back at the end of June, and we are covering the same topics. You know, we kind of thought we'd start at the beginning with this software training and have Stan walk everybody kind of through just everything you need to know about the software from A to Z. So we're still at point A, but because we're trying to keep the audience levels a little bit smaller so that we can have some interaction, we thought we better offer these topics multiple times so that folks get an opportunity to join in. So we'll consider this one part one, and we will definitely be doing a part two hopefully next month. And then we'll probably rerun part two a couple times as well. So just kind of giving you all a heads up on kind of how this is all working. And as I said, we want to try and make these interactive. So as we go along today, if you have questions, there's a way for you to you can raise your hand, and that'll let me know that you've got a question, and if you are able, I can unmute you if you've got a speaker, and you can actually ask your question live right to Stan. So if that's a way that you want to participate, that'd be great. So again, you can just raise your hand and I'll unmute you and you can ask it that way. Or if you don't have speakers or a microphone rather, there is the little questions chat box, and you're more than welcome to just type your questions in there and I can ask Stan the question for you. So I guess without further ado, we'll just go ahead and get started here. I'm going to change the screen over to Stan. And there we go.
Okay, can you see my screen?
Yes, it is there.
Perfect. Thank you, Maureen. Good afternoon, everybody. Basically, in this session right here, like I said probably a couple weeks ago, I'm just going to basically go over the system requirements to run DMS, talk about the preferences within DMS, and talk about the different levels of the hierarchy in DMS. And then lastly, at the end, I'll be discussing the walkthrough of how you guys will go through there and actually create names for each individual machine, test point, and then try to incorporate that within DMS. So periodically throughout the session, I'll stop and ask if you guys have any questions, and if you guys do, you can just let Maureen know, and then Maureen will actually let me know if there is a question out there. Okay, what is DMS? Well, the DMS is basically a data management software, and basically what that does, it actually forces us to make our facilities into smaller manageable groups so that we can actually upload and download information to and from our UltraProbe so that this program will actually start trending the decibel levels within, let's say, a bearing route, so that you guys can actually see a glimpse of what is actually happening to a particular bearing over time. Within this DMS, you guys can actually create different types of reports for different types of applications that you guys are using the program for. If you guys don't have the latest version of DMS, you guys can actually download the latest version, which is version 5.2 off of our website. And when you guys download that version, it will actually be a zip file. So once you actually download that zip file, you will actually have to unzip that file to get to the install program so that you guys can install it properly onto your local drive. Now, for the system requirements, you will need this. You'll need at least 1 gig of RAM, which is required. 2 gigs is suggested. I would advise you guys to jump up to maybe 4 gigs. That's typical for most computers now. The operating systems, you will need at least Windows XP, Vista, Windows 7, or 8. Anything before Windows XP, it just won't work. And the version of Excel that you guys will need to run the reports, you'll need at least 2007 or greater. Anything before 2007, it will not work because the format is totally different from the previous versions of 2007. So you need at least 2007 or greater to create these reports. Now, when you install the program, it would actually be in your startup menu under All Programs, and it'll say UltraTrend DMS 5. Now what you guys can do to create a shortcut is find that program, open that up, and you have this icon here. And what you guys can do is you can actually click it and then drag it to your desktop. So now all you guys got to do is just double click on the shortcut and your DMS will actually pop up. Now within DMS you have an edit tab. If we open this up and we go into the edit preferences, you can actually choose what type of language that you want to use. We're constantly adding new languages to this program. You can choose your type of units. If you're in the US, you'll probably be using standard, and then everybody else will actually go with metric. The currencies that we actually have is the US dollar, the British pound, and then the euro. Excuse me. And then below that will be your display alarm groups. And basically what this is once you guys establish your baseline readings for, let's say, bearings, you can actually create alarm levels for those particular bearings. And anything that actually hits an alarm state, like a low-level alarm or high-level alarm, will be stored into this one particular group. You can actually have it set up to have it above your group data. You can have it set up for your below group data, or if you don't want to see your alarm groups at all, you can just click on Do Not Show. If you guys want the alarm groups, I advise you guys to use it so that you guys have it set up for the below group data. If you have it above and you do expand all, for instance, if I open up my database here and go into my bearings, here are my groups I actually have, which I'll discuss a little bit later on, but you have a points currently in. If you open this up, you'll have your alarms. So if we have it set up on top and we do an expand all, if we look at the very bottom of our list of all the data that we have collected, it gets a little bit confusing if you have the points currently in on top of your group. Okay, so if you guys are going to be doing DMS and you're using it for the first time, just make sure that you have the below the group checked. And then finally, underneath the General tab, we have a check for updates. Periodically, whenever you open up DMS and if you have an internet connection, it will actually send out a signal to our servers and basically check to see if there's a later version of DMS. If you have an older version of DMS, it will not work because it's not incorporated within the older versions. It's actually incorporated with this new version of 5.2. So over time, if we decide to put a new version of DMS onto our servers, the next time you guys open up DMS, it'll actually send out a signal to our servers and basically check for a later version of DMS. And then it'll actually pop up saying that there is a newer version do you want to download, and just click on yes if you want to. The next tab underneath the Edit Preferences is the Backup Settings. If we click on the Backup Settings, you have 4 different options. And basically, if we check the closing group, anytime we close out of a group and open up a new one, it will actually create a backup file. Or if you decide to go with importing records, anytime you import a record from one of your UltraProbes and put it into DMS, it will create a backup file that way. The 2 lesser known ones that people normally don't use is splitting of a group. Basically, if your group is too big and you split that group, it will create a backup file there. Or if you're moving test points around within a particular group, it will create a backup file that way. The most common one that everybody uses is the closing of the group. So if you close out of group again and move into another group, it'll create a backup file. So if your system crashes for whatever reason and you can't retrieve your plant from your DMS plant folder, you can actually retrieve the backup files and then reincorporate that within your DMS plant folder. And then lastly, you got your Path tab. This is basically where everything is going to be stored. Your DMS plant folder that's going to be storing all your data will be stored right here on your local drive, and it will be called the DMS plant folder. If you have a network drive and you want to place that folder onto the network drive, it will probably say something else like the S drive or the Q drive, and then wherever this plan is actually located, it will be stored right here. The backup folder, you might want to just leave it on your C drive, especially if you have all your data stored on the network drive. This will be the location where it's actually going to be storing all the backups. So if anything happens up in here, you can actually come down in this folder here and retrieve that data and then reincorporate that within the DMS plant folder up here. And then finally, the spectralizer path. You want to leave this alone. This is for people that have the UltraProbe 10,000 or 15,000 so that they can actually analyze their sound recordings. You want to leave this alone. So the DMS plant folder and the backup folders you can manipulate a little bit depending on what kind of configuration that you guys actually have at your facilities. Any questions thus far, guys?
Yeah, Stan, we do have a hand that's raised, so I just want to make sure. David Engel has his hand up, so I'm going to unmute you, David, and if you still have your question, you can ask it. David? All right, well, maybe he stepped out, but we did have another question come in, Stan, so I will ask this one. This one was just written in. So just wondering if using a network drive affects the performance of the software, and if two people can be using the DMS plans folder at the same time.
Okay, you can't have two people looking or manipulating a particular database at one time. Only one person can be on there at one time to do any modifications within that group. The program itself, the software, needs to be installed onto the local drive. It will not work if you have it installed onto the network drive. It will actually just crash the system. So you want to make sure that when you do the install, you want to install that program onto the local drive, your C drive, and then the data itself that you guys are actually collecting over time, that can actually be stored onto the network. You cannot put that software onto the network drive. It just will not work. Maureen?
Okay. Yep. Perfect. Okay. I was just looking to see if there was any other question before we let you move on to the next section, but I think we're good.
Okay. All right. Now the next step is basically teaching you guys the different levels of the hierarchy within DMS. When you guys first go out there and you create your groups, your routes, and so on within a particular plant, you'll have different levels of the hierarchy within DMS. So the first level that we're going to see is this level right here. I have my Toyota highlighted, and basically this is my plant level. Now this can be named any which way that you want to name it. It doesn't have to be a facility that you work at. You know, most guys go to the same job over and over again. They know exactly the name of the plant that they're going to. So it could be broken down into smaller groups, like if you have several buildings, the plant name could be a particular building that you guys are actually focusing in on. It could be a particular room, it could be a section of the building that you're actually concentrating on your data collection. So it can be named any way that you want it to be named. So it gives you free reign on that. Below that is basically your application level. And the application level is fairly important because it actually has added features for each individual application level. So if we open up my bearing and just highlight a particular historical data, you can actually see over in the far right hand side of DMS, you can actually see that we actually have like an RPM speed. So if we have a bearing that fluctuates in speed and we record it at, let's say, 1750, we can actually document that. But if we come over here to my electrical application and highlight a historical record, we don't have the RPM speed anymore. We actually have like voltages, item components. You know, if we were dealing with a switchgear, you can actually put in a specific voltage that we're actually testing. the humidity. So the application level is fairly important because you'll have extra features that you can actually add to a particular part that you guys are actually testing. Oops, let me move this back. Now below the application level, we have our group level. And the group level is really important because this is where you guys are going to be uploading and downloading information to and from your UltraProbe. So the group level could be a particular area within a particular building that you guys are actually focusing in on. It could be, you know, in this case right here, I have an engine room that I'm actually testing. So within that group, within that room of the engine, we have all my machines or my locations. So I'll actually create names for each individual machine. And in this one room, we actually have 3, 4, 5, 6, 7 machines in there that I want to focus in on and actually collect data with my UltraProbe so that I can actually start trending over time these particular bearings within these machines. Below the machine level is our individual test points, and in this case, the individual bearings that we're actually testing. So in the first one we come up to, the alternator, we have one bearing called the tail. If I go to my block machine, I actually have 6 points. So within this group, we have our machine level, and then underneath the machine levels, we actually have all of our bearings for each one of those individual machines that we actually created names for. And if we open this up one more time underneath the point level, we have our historical data. This is all the information that we have collected over time with our UltraProbes, and this program will actually trend those dBs over time. Excuse me. So you can actually see here our first test point was dated back on May 4th of 2008. So we've been collecting data since then, and you can actually see that we actually have different colors within this one test point. If you see stuff that's in yellow, it basically means, let me highlight this one. If it's in yellow, it basically means that we hit a low-level alarm. So if we're dealing with bearings, for instance, anything usually hits a yellow alarm or a low-level alarm, it basically tells us that we have a lubrication problem. There's nothing really wrong with the bearing, it's just dry. So you would actually go out there and start greasing that bearing and see if it will actually quiet itself down, lower the dB level, so to speak. Anything that pops up as red is basically a high-level alarm. And dealing with bearings, anything that pops up as a red flag usually tells us that we have beginning stages of physical damage that we can actually see with our own eyes. So you can actually see the flaking, the spalling, even sometimes flat spots on the bearing itself. So it gives you indications of what's actually happening inside that bearing without really tearing anything apart. So it's very non-destructive using UltraProbes for this application. Now, for the group level, you guys can have up to 400 test points for each individual group. You can't go beyond that. Having 400 test points, it's a lot, but it's very impractical. You don't have enough time to actually collect the data and then have enough time to actually analyze that data in a day. So typically when we actually teach people the software, we always try to teach them to make sure that they create groups no greater than 100 test points. That way you have enough time to actually analyze it, and, collect the data, and then have enough time to actually analyze that data. Any questions on that, guys?
If anybody has a question, you can either raise your hand or pop it into the box. We did have one question that someone wrote in, just wondering, just to clarify, when you talk about a group, is the group a route, or is that, if maybe you can just clarify that?
The group is the route. The route is the group. It's the same thing.
Okay. Perfect. All right. I think that's it for right now.
All right. Well, you guys are quiet today.
All right. Giving them all the info.
Now the last part is going to be discussing the walkthrough. This is very important. Before you actually touch DMS, you want to make sure that you do a walkthrough first. So if you decided you want to go to building 55, you want to go into the machine room, you go write down, the plant name, the application level that you're actually doing, the group name, which would be the machine room. And then inside that machine room would be everything that you guys will be trending over time. So you need a piece of paper and a pen, and the walkthrough should be pretty even flow. And what I mean about even flow is you want to start on one end and just go in a straight line and just follow, the flow of the machine. So if you're starting at, let's say if we're at a conveyor belt, we want to start at the very beginning of that conveyor belt. Either choose the left side or right side. It doesn't matter which way. You want to start on one end and just follow it all the way through until you reach the other end of the conveyor belt. Once you actually create individual names for those bearings on that one side, what you want to do is jump over onto the other side and start from one end and work your way to the other. This way you guys can just go ahead and just go down a nice straight line. You're not zigzagging back and forth from one end of the bearing to the next. It'll basically save you tons of time if you just go and just follow it in a nice straight line instead of zigzagging back and forth. When you actually create this walkthrough, like I said before, you have a piece of paper and a pen. So what you'll do is you're going to divide your paper in half. So what I mean about that is that if you have multiple machines, you want to create the names for each one of those individual machines on one side, on the left side of the paper. And then on the right side of the paper, you'll actually create individual names for those bearings for each one of those machines that you have just created. That way it will actually imitate the DMS program when it's time for you to actually start creating your route. It'll actually imitate that so that you can actually see exactly what it's going to look like once you actually create this in DMS. Also bear in mind, guys, is that if you guys have bearings, for instance, that's already been named, or if you're dealing with electrical applications, dealing with switch gears, and they've already had names for themselves, you want to make sure that you create the same names so that everybody understands exactly what you're talking about. So if you come up to a machine, let's say it's motor 1, for some of the vibration guys, they created a name for it called motor 1, and they created the bearings, MIB and MOB. You want to make sure that you actually imitate the same wording as the vibration guys. So if you do have an issue with a particular bearing, you can say, hey, I got an issue with motor 1 on the MIB side. The vibration guys and everybody else that's involved with that will actually understand exactly what you're talking about, where it's actually being, where the problem lies within this particular room. So it's very important that if stuff has already been named, you want to make sure that you use the same name for DMS so it matches up with other technologies that you guys might have out there. When you create these names, you want to avoid spaces, or you don't have to avoid spaces, but if you use a space in between letters, the spaces will count as a character. The next time I actually do the software, I'll explain about the characters where you actually have to use either the 13.3 format versus the 8 and 8 format. The spaces that you create for those names will be counted as a character. And you also want to avoid any special characters. You want to stick with the normal alphanumeric, ABC, 1, 2, 3. You don't want to use hyphens, commas, backslashes, and so on. It will not work. DMS doesn't like those special characters. And then finally, it's like I said before, it's a good rule to follow the flow of the machine that you guys are actually going to be creating names for, so that you guys can actually go into a nice straight line when you guys collect that data. And then after that, once you actually do the walkthrough, you guys are ready to actually create your plant, your group, and create your names of the machines and the test points within DMS. And I'll be discussing that in the next segment, probably sometime next month. I'm all done, Maureen.
All right. So we have a couple questions that came in on the alarms, and I know that's something you probably could go over in more detail on the next one
Mhm.
too, but since we've got a little time. So the first one was when you were talking about the low-level alarms, where were the set points?
The set points are basically your first initial readings that you guys actually take. If we go back to our bearings, if I open up my very first one, you'll see out of all this historical data, we actually have one that's actually in bold. When you actually see this in bold, it means this is our baseline reading. So we actually establish these alarms based off of this baseline reading. So if I highlight this, when we actually taken that reading, we actually had 20 dBs. So what I'll do is come over here to my alarm tab, and we can actually create alarm levels. In dealing with bearings, typically we always say 8 and 16. 8 decibels above its original baseline will pop up as a yellow flag telling us that we actually have a lubrication problem. And then 16 will be our high-level alarm, basically telling us that we have beginning stages of physical damage of the bearing. And what we'll do is we'll actually update all alarm levels using these deltas, and what it'll do, it'll add these values, 8 and 16, to every single one of these baseline readings within this group. So now, since I actually hit this, my baseline reading is 20, so it'll add 8 to it. So if anything that hits 28 dBs or higher, it'll pop up as a yellow flag, like over in here. And then anything that hits 36 will pop up as a red flag, stating that we actually have physical damage to the bearing. Now this will be different for every single point that we actually have, because if I highlight this next point down here, our baseline reading is 25. So now, instead of being 28, anything that hits 33 will pop up as a yellow alarm, which is a lubrication problem for this one particular bearing, and then anything that hits 41 will be beginning stages of bearing failure, of physical damage of the bearing failing.
Okay, cool. And I think that, I think that answered actually the other question that had come in. And then just one other thought as far as, setting these baselines and everything. Do you have some recommended practices for folks who have equipment that's, older, so they're not just, they're not getting to set it right from the beginning? What's kind of the best method for that?
That's probably one of the most common questions that we always get asked, is that, they have motors that are, machines that have been running for many, many years. And obviously they're not going to get, a true baseline reading. So what the guys can do is they can do a comparison. So if they got, let's say, 5 motors that are running the same speed underneath the same load, they can do a comparison to each other. So if you got 4 motors that are basically within the same ballpark from each other for dB wise, and then all of a sudden you come up to the 5th one and it's much higher than all the rest, then that 5th one is actually kind of bad. You want to try to focus in on that. Another way that you guys can try to establish a good baseline is before you actually collect data for the first time for those motors, for instance, you can try to grease those bearings and see if you guys can actually lower the dB value from there. If it does drop in dB value, you can then go ahead and collect data, and that will be your new baseline reading that you guys can go by.
All right, cool. And then another one came in just wondering how big the database can be. So what's the limit?
Well, the database itself, and like I said earlier, for the group level, you can have up to 400 test points. I've seen people with 200, 250 test points, but we always try to keep people on the low side so that they actually have enough time to actually collect the data and analyze it. So we always say around 100 test points per group. Now, for the plant level, you can have an unlimited amount of groups that you guys can have. You guys can have thousands of groups for one particular plant level. So for this one here, for my Toyota, I actually have, for my bearing application level, I have 5 groups. Now this could be 1,000 groups underneath this one particular bearing application. It's unlimited. But once you get down to the group level, you can only max out to 400 test points. But for the plant level itself, for the application level, you guys can have unlimited amount of groups within that database.
Okay, perfect. Oh, looks like another one just came in. Okay, so here's a question. I think we're going back to the alarms as well. So when for yellow you said to grease the bearings, so would you also double check with the actual motor standards as well, or just grease as requested by DMS?
Basically, the old style is, and I still deal with some people that are still doing it with the old ways. Periodically, they go by a time-based lubrication where periodically throughout every couple months they would have to throw in, like, say, 10 to 20 shots of grease into that bearing, because that's what the manual in the paper is telling them to do. With ultrasound, you guys can use the ultraprobes to detect when the bearing is full. So what it does primarily, it helps us prevent ourselves from over-greasing the bearing or under-greasing the bearing. So even though the manual is telling us to grease it every 2 months with 10 shots of grease, this time around we might only need 2 or 3 shots. So the ultrasound is going to tell us exactly how much greasing needs for that one particular bearing. So using the ultrasound, the time base is really the way of the past. So the ultrasound is the way to go to help you guys prevent yourselves from destroying the bearings yourselves. So if the bearing does fail and you do your lubrication correctly with ultrasound, you can pretty much take the human factor out of it. You can look at other things that could be destroying your bearing, like maybe a misalignment somewhere within that machine. So if you do the lubrication correctly with ultrasound, you can pretty much eliminate the human factor out of it.
Yeah. So perfect, and obviously you could go into so much more. Well, we've had whole webinars on lubrication and condition-based monitoring with the ultrasound on your bearings and things like that. So just to point out to everybody, on our website we do have all of our recorded webinars, and we have one specifically on there about using ultrasound for lubrication best practices. So that'd be a good one to check out if you have just during your lunch hour or whatever, like you're doing today. That would probably be a really good one. And then Stan also went over in pretty good detail how to do the walkthrough, and I just wanted to also mention that Stan writes usually a monthly blog post for us, and covers different topics, and then that are in nice short little writing. And he did a specific one on how to do the walkthrough. So if anybody's looking for more of like a step-by-step, that you can just read, you can go to the uesystemsblog.com site and look that up there. He's also had some other good topics as well that you can read about. So just kind of pointing out, we've got lots of different places to go for this different information, and obviously just our effort to be a resource for everybody. So Stan, I don't see any other questions coming in, but obviously everybody, you guys know how to get in touch with us and how to be in touch with Stan. So if you think of questions after we knock off here, certainly feel free to just send those in. Just want to point out some important dates before we wrap up for the day. Our next regular webinar, so you all are obviously get the invites for those too, is going to be not next Tuesday, in 2 Wednesdays, August 14th. And we've got Tim Dutton coming to talk about managing your metrics and KPIs, so that'll be a really good session. And then we've got one coming up on planning and scheduling in September. And of course we always want to make you aware of our Ultrasound World Conference, which we've got the dates scheduled for that for next May 13 through 16. We will be working on getting a date put together for the next software training course. So look for that. That'll probably be towards the end of August. And as I said, we're going to probably do part 2 next month, and we'll probably run that one again, and we'll probably run this part 1 again as well. So if you've got colleagues that couldn't make it, obviously just tell them to keep an eye out for the invites so they can participate when they have time. And with that, I will just leave our contact us screen up here. So again, if anybody has questions, this is how you can be in touch with us. And hope everybody has a great afternoon. And thanks again, Stan.
Thank you, guys.